Close your eyes for a moment and imagine you're floating in the vastness of space, surrounded by an endless sea of stars. Far beyond the planets, two tiny spacecraft, Voyager 1 and Voyager 2, are drifting through the cosmic unknown, carrying humanity's dreams on a journey no one thought possible. Launched in 1977, these scrappy explorers have been zipping through the universe for nearly 5 decades, outlasting bell-bottoms, floppy disks, and even the Walkman. They're not just machines. They're our cosmic messengers, boldly going where no one has gone before. So, what have they uncovered at the edge of our solar system that's so jaw-dropping, NASA's still grappling with the implications? Strap in, because you're about to take a wild ride to the fringes of our cosmic backyard. Let's rewind to the 1970s. The world's grooving to disco, Star Wars is sparking imaginations, and NASA's cooking up something revolutionary. The Voyager program was born from a rare cosmic event, a planetary alignment that happens once every 175 years, letting the spacecraft slingshot from planet to planet like interplanetary pinballs. Picture the scene at NASA's Jet Propulsion Laboratory. Engineers in sideburns and polyester shirts, hunched over bulky computers, their eyes gleaming with ambition. The air hums with the clatter of keyboards and the faint aroma of instant coffee. This was the space age, a time when humanity dared to dream big, and the Voyagers were the embodiment of that audacity. They weren't just built to visit Jupiter or Saturn. They were designed to push past the known, to touch the edge of the solar system and maybe, just maybe, say hello to the stars. Why does this matter to you? Because the Voyagers are more than machines. They're a piece of you, a piece of us. Imagine you're one of those NASA scientists, waiting for a signal from Voyager 1, now over 15 billion miles away. That's so far that light from the sun takes over 22 hours to reach it. If you sent a ping to Voyager, you'd be twiddling your thumbs for nearly a day before it replied. It's like texting a friend on the other side of the galaxy and hoping they've got good Wi-Fi. Every signal that comes back is a miracle, a faint whisper across the void, carrying secrets from a place no human will ever set foot. The Voyager's journey began with a historical stroke of luck. That planetary alignment was a cosmic gift, letting Voyager 1 visit Jupiter and Saturn, while Voyager 2 went for the Grand Slam, swinging by Uranus and Neptune too. These weren't just sightseeing trips. The spacecraft sent back images that changed how we see the solar system. Jupiter's great red spot swirling like a cosmic hurricane, Saturn's rings gleaming like a celestial vinyl record, and Neptune's ethereal blue glow. But the real kicker? They didn't stop there. They kept going past the planets, into a region we call the Heliosphere, the bubble of solar wind that surrounds our solar system. And that's where things start getting weird. The edge of the solar system isn't a neat line in the sand. It's a chaotic, fuzzy boundary where the sun's influence fades and the vastness of interstellar space takes over. You might picture it as a quiet, empty void, but it's anything but. The Voyagers are sailing through a cosmic no-man's land where magnetic fields twist, particles dance, and the rules of physics get a little funky. Scientists expected this region to be strange, but what Voyager found was stranger than anyone imagined. For instance, Voyager 1 picked up a mysterious hum in interstellar space, a low-frequency vibration that's got researchers buzzing with theories. Is it just plasma waves? A quirk of the interstellar medium? Or, let's get wild for a second. Could it be something we don't yet understand? Now, before you roll your eyes and say, NASA's hiding alien signals? Really? Hear me out. The shocking part isn't about tinfoil hat conspiracies. It's about data so bizarre, it's forcing scientists to rethink their models of the universe. The Voyagers are sending back measurements of magnetic fields, cosmic rays, and plasma that don't quite fit our textbooks. Some researchers argue these anomalies could hint at new physics, while others insist it's just the universe being its usual, complicated self. Either way, the debate is heating up, and the Voyagers are at the center of it, like two tiny detectives uncovering clues in a cosmic mystery. As you imagine these spacecraft drifting through the void, picture their dish antennas pointed back at Earth, beaming data across billions of miles. The signal is so weak, it's like catching a whisper in a hurricane. Yet NASA's Deep Space Network is still listening, still decoding those precious bits of information. It's humbling, isn't it? These machines, launched when your grandparents were probably rocking platform shoes, are still out there, still talking to us. They're like the ultimate overachievers, refusing to retire even as their power fades. And here's a quirky tidbit. Each Voyager carries a golden record, a literal message in a bottle for the cosmos. It's packed with sounds of Earth, music, greetings in 55 languages, even the sound of a kiss. Imagine an alien finding it eons from now, popping it onto their cosmic turntable and hearing Bach or a whale song. Would they think we're cool? Or just really into whales? It's a reminder that Voyager isn't just about science. It's about humanity's need to connect, to reach out, to say, we're here and we're curious. So, why should you care about two old spacecraft drifting at the edge of nowhere? Because they're proof that we can do impossible things. They're showing us that the universe is weirder and more wonderful than we ever dreamed. And they're still out there, pushing the boundaries of what's possible, even as their batteries run low. Before we dive into the nitty-gritty of what they've found, let's hear from you. What do you think is out there at the edge of the solar system? Aliens? New physics? Or just a whole lot of nothing? Drop your thoughts in the comments, and let's keep this cosmic journey going. You're hurtling through space, leaving behind the familiar glow of Jupiter, Saturn, and the outer planets. The sun, once a blazing beacon, is now a distant speck, barely brighter than the stars around it. You're riding along with Voyager 1 and 2, those scrappy spacecraft launched in 1977, as they venture into a region so strange, it feels like the universe is playing a cosmic prank. This is the Heliosphere, the sun's protective bubble, where solar winds clash with the wild, untamed forces of interstellar space. It's not a clean border. It's a turbulent, chaotic frontier, and the Voyagers are sailing right through it. Get ready, because you're about to explore a region that's rewriting our understanding of the solar system's edge. Imagine you're aboard Voyager 1, a tiny craft no bigger than a small car, floating in an endless sea of darkness. The sun's warmth is a distant memory. Its light so faint you'd need a telescope to feel its presence. The heliosphere surrounds you, a vast bubble of charged particles and magnetic fields blown outward by the sun. It's like a cosmic force field, shielding our solar system from the galaxy's harsh radiation. But this bubble isn't smooth or tidy. It's stretched and warped by the interstellar medium, the soup of gas, dust, and plasma that fills the space between stars. You can almost feel the tension, like standing at the edge of a storm where two massive forces collide. Back on Earth, when NASA launched the Voyagers in 1977, the heliosphere was more of a theoretical idea than a place we could touch. Scientists like Eugene Parker, a pioneer in solar physics, proposed the concept of the solar wind in the 1950s. A stream of charged particles streaming from the sun. But what happened when that wind hit the galaxy's edge? No one knew for sure. The Voyagers were sent to find out, And as they approached the heliosphere's outer layers, their data started painting a picture of a region far weirder than anyone imagined. Picture the NASA control room. Engineers in retro glasses, poring over printouts, their excitement palpable as Voyager's signals revealed a cosmic border unlike anything in their models. Let's break it down. The heliosphere is shaped by the solar wind pushing outward against the interstellar medium pressing inward. It's a dynamic, ever-shifting boundary, like the surface of a soap bubble caught in a breeze. As Voyager 1 and 2 moved through the heliosphere's outer layer, they started detecting dramatic changes. The solar wind slowed to a crawl, galactic cosmic rays grew stronger, and magnetic fields twisted in unexpected ways. It's like the universe decided to throw a curveball, and the Voyagers were there to catch it. One surprising detail? The heliosphere breathes with solar activity. When the sun unleashes flares or coronal mass ejections, the heliosphere expands and contracts, like a living thing responding to its environment. Here's a quirky fact to blow your mind. The heliosphere isn't just a passive boundary. It's home to magnetic bubbles, massive pockets of magnetic fields that can span 100 million miles. Discovered by Voyager 1, these bubbles form where solar and interstellar magnetic fields collide, creating a frothy, turbulent mess. Imagine a cosmic bubble bath, but instead of soap suds, it's filled with magnetic case and high-energy particles. Scientists were stunned. Nobody predicted this. These bubbles might even act like a cosmic filter, affecting how galactic cosmic rays reach Earth. Some researchers argue they could influence our planet's climate or even disrupt our tech, sparking lively debates about how connected our world is to the galaxy's edge. Speaking of debates, there's a big one in the astrophysics community. Some scientists believe the heliosphere's structure could unlock secrets about the galaxy's magnetic fields, potentially revealing new physics. Others argue we're just seeing the solar system's unique quirks, nothing revolutionary. The Voyagers are the only ones out there taking direct measurements, so their data is like a cosmic Rosetta Stone, fueling arguments and inspiring new theories. You can't help but feel a thrill imagining what these discoveries might mean. Are we on the cusp of a scientific breakthrough? Or is the universe just showing off its weird side? As you picture the Voyagers navigating this chaotic frontier, imagine the sensory experience. There's no sound in space, but if you could hear it, you might catch a faint, eerie hum. Plasma waves vibrating through the interstellar medium. The spacecraft are pummeled by cosmic rays, their aging instruments working overtime to capture every detail. It's a lonely, exhilarating journey, like sailing into a storm with no land in sight. Back on Earth, the NASA team, now a mix of young scientists and veterans, monitors these faint signals with awe. Every byte of data is a victory, a reminder that these 1970s relics are still out there, defying the odds. Let's lighten things up for a moment. If the Voyagers were people, they'd be the ultimate adventurers, the kind who'd backpack across the galaxy with nothing but a map and some duct tape. Built with tech older than most smartphones, they're still out there, sending postcards from the edge of the solar system. And if they could send a selfie, it'd probably show a weathered spacecraft with a cheeky grin, saying, "Still got it." It's hard not to admire their grit. The heliosphere's edge is more than a scientific puzzle. It's a symbol of human curiosity. The Voyagers are showing us that the universe is full of surprises, from magnetic bubbles to shifting boundaries. They're proving that even our best models can't predict everything. And that's what makes exploration so exciting. As they drift further into this strange frontier, they're sending back clues about what lies beyond the sun's reach. What's next? The heliopause, the final boundary where the solar system ends and the galaxy begins. Get ready, because the Voyagers are about to take you even deeper into the unknown. You're standing at the edge of everything you've ever known, where the sun's influence fades into the vast, untamed wilderness of interstellar space. Voyager 1 and 2, those plucky spacecraft from 1977, have crossed into the heliopause, the final boundary of our solar system. This isn't a neat line drawn in the cosmic sand. It's a turbulent, invisible frontier, where the solar wind bows out and the galaxy's mysteries take center stage. You can feel the weight of the moment, like standing at the edge of a cliff with the universe stretching out before you. The Voyagers are sending back data that's turning NASA's models upside down, revealing a boundary so strange it's sparking debates and rewriting what we thought we knew. Let's dive into this cosmic threshold and uncover what makes it so breathtakingly bizarre. Picture yourself aboard Voyager 1, now over 15 billion miles from Earth. The sun is a faint, lonely star, its light barely cutting through the darkness. You're in the heliopause, where the solar wind, a stream of charged particles from the sun, finally loses its fight against the interstellar medium, the gas, dust, and plasma that fills the space between stars. It's like standing where a river meets the sea, the currents swirling in chaotic, unpredictable patterns. The heliopause is dynamic, rippling with plasma waves, magnetic fields, and cosmic rays from distant supernovae. You can almost sense the energy, the clash of two cosmic realms, like a storm brewing at the edge of forever. When NASA launched the Voyagers in 1977, the heliopause was a distant dream, a theoretical boundary few thought we'd reach in their lifetimes. Scientists knew the sun's solar wind created a protective bubble, the Heliosphere. But where did it end? The Voyagers were built to find out. And as they approached this frontier, their data started pouring in, painting a picture of a region far weirder than anyone expected. Imagine the NASA team in Pasadena, gathered around monitors, their excitement palpable as Voyager 1 signals confirmed it had crossed the heliopause in August 2012. It was a historic moment, like the first human stepping onto a new continent, except this continent was a shifting, invisible boundary billions of miles away. Let's break down what's happening. The heliopause is where the solar wind's outward push balances the inward pressure of the interstellar medium. As Voyager 1 crossed this boundary, its instruments detected a sharp drop in solar particles and a surge in galactic cosmic rays, high-energy particles from exploding stars and other cosmic events. The magnetic fields shifted too, aligning more with the galaxies than the sun's. It's like stepping from a warm, familiar house into a wild, stormy landscape where the rules are different. The transition wasn't smooth either. Voyager 1 passed through a depletion zone, a region where particle density dropped unexpectedly, like hitting a cosmic pothole. Scientists are still puzzling over this zone. Is it a quirk of the heliopause's structure, or a hint of something stranger, like interactions with unknown galactic forces? Here's a quirky tidbit. Voyager didn't announce its heliopause crossing with a fanfare. Instead, scientists had to decipher subtle clues from its plasma wave instrument, which picked up oscillations in the surrounding plasma. It was like Voyager was sending a coded message, "Hey, I'm in interstellar space now." And NASA had to crack the code. This discovery wasn't just a technical feat. It was a testament to human ingenuity, piecing together a cosmic puzzle from faint signals across billions of miles. The heliopause has sparked heated debates in the scientific community. Some researchers argue it's a porous boundary, letting cosmic rays slip into the solar system in ways that could affect Earth's climate or technology. Others see it as a dynamic shield, shaped by the sun's activity and the galaxy's magnetic fields. The Voyager's data is the only direct evidence we have, making every measurement a treasure. You can feel the buzz in the astrophysics world, Like detectives chasing a lead that could crack the case wide open. Are we uncovering secrets about the galaxy's structure? Or is the heliopause just a peculiar feature of our solar system? Let's anchor this in history. The heliopause builds on ideas from the 1950s, when Eugene Parker proposed the solar wind's existence. His theories laid the groundwork for understanding the heliosphere. But it was Voyager's data that turned speculation into reality. When Voyager 1 crossed the heliopause, it confirmed Parker's ideas and added new twists, like the unexpectedly dense interstellar plasma. It's a reminder that science is a journey of discovery, where each answer sparks new questions, and the Voyagers are our trailblazers. As you imagine the heliopause, picture a shimmering, invisible curtain rippling in the cosmic wind. If you could hear it, you might catch a faint, eerie hum. Plasma waves vibrating through the interstellar medium, like the universe's own heartbeat. Voyager's instruments are battered by cosmic rays, their 1970s tech straining to capture every detail, yet still beaming data back to Earth. It's a lonely, exhilarating scene, like standing at the edge of a cliff with the galaxy unfolding before you. Back on Earth, NASA's Deep Space Network listens for these faint signals, each one a triumph of engineering and curiosity. For a light-hearted break, imagine the heliopause as the solar system's VIP line, and the Voyagers as the cool kids who snuck past the bouncer. Built with tech older than most of our viewers, they're out there, casually exploring interstellar space. If they could send a selfie, it'd probably show a weathered spacecraft winking at the camera, saying, "Told you I'd make it?" And here's a fun thought. If Voyager sent a postcard from the heliopause, it'd read, "Greetings from the edge, wish you could see this view." The heliopause is more than a scientific milestone. It's a symbol of human ambition. The Voyagers have shown us that the universe is full of surprises, from shifting boundaries to mysterious plasma waves. They're proving that our neat models can't capture the cosmos's complexity, and that's what makes exploration so thrilling. As they drift through this frontier, they're sending back clues about what lies beyond the sun's reach. Clues that might reshape our understanding of the galaxy. Up next, we'll dive into the shocking data they've uncovered and why it's got NASA buzzing with questions. You're drifting through interstellar space, far beyond the sun's faint glow, with Voyager 1 and 2 as your guides. These tiny spacecraft, launched in 1977, are sending back data that's making NASA scientists sit up straight, their coffee forgotten as the numbers roll in. You're no longer in the solar system's cozy bubble. This is the interstellar medium, a wild, untamed frontier where the galaxy's rules take over. The Voyagers are uncovering phenomena so bizarre, they're challenging everything we thought we knew about the universe. From mysterious plasma waves to magnetic fields that don't play by the rules, these discoveries are shocking, thrilling, and maybe a little unsettling. Get ready to dive into the data that's got the scientific world buzzing with questions. Imagine you're in NASA's control room, staring at a screen filled with Voyager's telemetry data. The numbers are faint, transmitted across 15 billion miles. Each one a precious whisper from the edge of the cosmos. You feel a rush of adrenaline as the data reveals something unexpected. A low, persistent hum in the interstellar plasma. Magnetic fields twisting in strange ways, and cosmic rays surging like a cosmic storm. It's like the universe is sending you a coded message, and the Voyagers are the only ones close enough to decode it. The air crackles with excitement, maybe even a hint of unease, as scientists realize these findings don't fit their neat diagrams of the galaxy. Let's break it down. When Voyager 1 crossed the heliopause in 2012, it entered the interstellar medium, the sparse dynamic mix of gas, dust, and plasma that fills the space between stars. Voyager 2 followed in 2018, doubling our view of this alien landscape. Scientists expected differences from the solar system, but what they got was a cosmic surprise party. One of the most startling discoveries was a faint hum detected by Voyager 1's plasma wave instrument. It's not the soundtrack to an alien rave, but a low-frequency vibration in the interstellar plasma, like the universe's own pulse. You can almost hear it. A deep, eerie drone echoing through the void, hinting at forces we're only beginning to understand. What's causing this hum? The interstellar medium is a complex environment, filled with plasma waves, magnetic fields, and cosmic rays from distant supernovae. Voyager 1 measured a plasma density much higher than expected, suggesting the interstellar medium is denser and more dynamic than our models predicted. Voyager 2 added another twist, detecting magnetic fields at the heliopause that were misaligned with both the Sun's and the galaxy's fields. It's like the universe decided to rearrange the furniture just to keep us guessing. These findings paint a picture of a turbulent, chaotic boundary, far from the clean transition scientists hoped for. Here's a quirky detail to lighten the mood. Voyager's instruments, built with tech older than most streaming services, are detecting phenomena we didn't even know existed when they launched. The plasma wave instrument picking up that hum? It was designed to study Jupiter's magnetosphere, not interstellar space. It's like using a typewriter to discover a new element. Pure, unexpected brilliance. Scientists are now debating whether the hum is caused by plasma oscillations, interactions with nearby stars, or something entirely new. Some even wonder if it's a signature of galactic processes we haven't yet grasped. Let's anchor this in history. The Voyager program was born in the 1970s, a time when space exploration was a bold statement of human potential. Launched during the Cold War, the mission was championed by visionaries like Carl Sagan, who saw it as a way to explore the cosmos and reach out to potential extraterrestrial life. The interstellar medium was a distant concept back then, but Voyager's data is turning it into a vivid reality. When Voyager 1 detected that plasma hum, it confirmed theories about the interstellar medium while raising new questions, proving that science is a never-ending adventure. The discoveries are fueling lively debates. Some scientists argue the plasma hum and magnetic anomalies could point to new physics, maybe undiscovered particles or forces shaping the interstellar medium. Others insist it's just the galaxy's complexity, and our models need refining, not reinventing. The Voyagers are the only ones out there taking direct measurements, making their data a goldmine for researchers. You can feel the buzz in the scientific community, like they're on the verge of a breakthrough or a really heated argument at the next conference. Are these findings a glimpse into the galaxy's deeper structure? Or just the universe's way of keeping us humble? As you picture Voyager drifting through this strange new world, imagine its antennas pointed back at Earth, sending faint signals through a storm of cosmic rays. The interstellar medium is a harsh place, with plasma waves rippling like an invisible ocean and magnetic fields twisting in unpredictable ways. If you could stand there, you'd feel the galaxy's vastness pressing in. A humbling reminder of our place in the cosmos. Back on Earth, NASA's Deep Space Network is listening, capturing every byte of data like treasure from a distant land. Each signal is a testament to the Voyager's resilience and human curiosity. For a light-hearted break, imagine Voyager as the ultimate cosmic nerd, out there collecting data while the rest of us are binge-watching sci-fi. Built with tech from the era of disco, it's like they're saying, "Hold my floppy disk, I've got a universe to explore." And if Voyager could send a status update, it'd probably read, "Just found a cosmic hum, no biggie, just rewriting astrophysics. You good?" These shocking discoveries are more than data points. They're a window into the universe's deepest mysteries. The plasma hum, the misaligned magnetic fields, the surge in cosmic rays. They're all clues to how our solar system connects to the galaxy. Are they hinting at new physics, or just the universe's quirky personality? The Voyagers are showing us that interstellar space is alive with surprises, and we're only scratching the surface. Next up, we'll explore whether these strange signals could point to something even wilder, like signs of life beyond our solar system. You're floating in the interstellar void, far beyond the sun's faint glow. With Voyager 1 and 2 as your only companions. These tiny spacecraft, launched in 1977, are humanity's farthest explorers, sending back whispers from a realm so alien it feels like a sci-fi movie. The data they're collecting, mysterious plasma waves, strange magnetic fields, and surging cosmic rays, has NASA scientists buzzing with questions. But there's a bigger, more thrilling possibility. Could these signals hint at life beyond our solar system? The Voyagers haven't found aliens waving hello, but their discoveries are strange enough to spark wild speculation. Get ready to dive into the cosmic what-ifs and explore whether the universe might be a little less lonely than we think. Picture yourself aboard Voyager 1, drifting through the interstellar medium, 15 billion miles from home. The sun is a distant speck, barely brighter than the stars around you. You're surrounded by an endless sea of darkness, punctuated by the faint hum of plasma waves and the crackle of cosmic rays. It's exhilarating, but also humbling, like standing at the edge of an infinite abyss, wondering if something is staring back. The Voyager's instruments are picking up signals that don't quite fit our models, and every anomaly raises a tantalizing question. What if this is more than just physics? What if it's a clue to something alive out there? You can feel your pulse quicken at the thought. When NASA launched the Voyagers in 1907, their primary mission was to explore the outer planets, Jupiter, Saturn, Uranus, and Neptune. But there was always a grander dream: the search for extraterrestrial life. Each spacecraft carries a golden record, a cosmic message in a bottle with sounds and images from Earth, designed to communicate with any intelligent beings who might find it. Now, as Voyager 1 and 2 drift through interstellar space, their instruments are detecting phenomena that make scientists pause. That plasma hum picked up by Voyager 1? Those misaligned magnetic fields found by Voyager 2? They're likely natural, but their strangeness fuels speculation. Imagine the NASA team, huddled over their monitors, debating whether these signals are just cosmic noise or something more profound. Let's break down the science. The interstellar medium is a dynamic environment, filled with plasma waves, magnetic fields, and cosmic rays from distant supernovae. Voyager 1's plasma wave instrument detected a persistent, low-frequency hum in 2021, suggesting the interstellar medium is denser and more active than expected. These waves could be caused by natural processes, like shock waves from nearby stars or galactic events. But some researchers can't help but wonder, could they carry patterns that hint at artificial activity? Voyager 2 added fuel to the fire, detecting fluctuations in cosmic ray intensity that suggest the interstellar medium is influenced by forces we don't fully understand. It's a long shot, but in the absence of other probes in interstellar space, every anomaly gets a second look. Here's a quirky detail to spark your imagination. The golden records include a map showing Earth's location relative to 14 pulsars, cosmic lighthouses that emit regular pulses. This map was meant to help aliens find us, but here's the fun part. Voyager's instruments are sensitive enough to detect pulsar signals themselves. What if they picked up a signal that matched one of those pulsars, or something mimicking it? It's probably just cosmic noise. But the idea of Voyager accidentally intercepting an alien reply is enough to make you smile. It's like sending a message in a bottle and getting a cryptic text back. Let's anchor this in history. The search for extraterrestrial life took off in the 1960s with programs like SETI, which scanned the skies for radio signals. The Voyager mission, championed by Carl Sagan and others, was steeped in this optimism. The golden records were a bold gesture, a way to say, we're here and we're curious. Now, decades later, the Voyager's interstellar data is reigniting that hope, even if it's just a flicker. The plasma hum and cosmic ray fluctuations aren't proof of aliens, but they remind us why we explore, to answer the big questions, like whether we're alone in the universe. The scientific debate is electric. Some researchers argue that any unusual signal, like the plasma hum, should be analyzed for artificial patterns, just to be safe. Others scoff, saying the interstellar medium is complex enough without invoking extraterrestrial intelligence. The Voyager's data is the only direct evidence we have from interstellar space, making it a battleground for ideas. You can sense the tension, like a room full of scientists arguing over a cryptic clue. Are these anomalies just the galaxy's quirks? Or could they be a faint echo of something alive? The truth is out there, and the Voyagers are our only shot at finding it. As you visualize the Voyagers in this cosmic wilderness, imagine their antennas pointed back to Earth, sending faint signals through a storm of cosmic rays. The interstellar medium is alive with activity, plasma waves rippling like an invisible ocean, magnetic fields twisting in unpredictable ways. If you could stand there, you'd feel the galaxy's vastness, its mysteries pressing in from all sides. Back on Earth, NASA's Deep Space Network is listening, capturing every bite like archaeologists unearthing a lost civilization. Each signal is a testament to human ingenuity and the Voyager's relentless spirit. For a light-hearted break, picture Voyager as the ultimate cosmic detective, snooping around interstellar space for clues. Built with tech from the disco era, it's like they're solving mysteries with a Polaroid and a walkie-talkie. If Voyager could send a status update, it'd probably say, "No aliens yet, but I'm picking up some weird vibes. Stay tuned." And here's a fun thought. If Voyager did find an alien signal, it'd probably be something boring, like a cosmic spam call. Greetings, Earthlings. Want to extend your spaceship's warranty? The possibility of life beyond Earth is what fuels exploration. The Voyager's data, plasma waves, cosmic rays, magnetic anomalies, is pushing us to ask big questions. Are these signals just the universe's background noise? Or could they be a whisper of something more? The Voyagers haven't found aliens, but they've given us a reason to keep looking. Next up, we'll dive into the golden records, humanity's message to the stars, and why they might be our best shot at connecting with the cosmos. You're drifting through the interstellar void, billions of miles from home, with Voyager 1 and 2 as your guides. These tiny spacecraft, launched in 1977, carry something extraordinary, a golden record, humanity's boldest message to the cosmos. It's not just a piece of tech, it's a time capsule, a cosmic love letter, a snapshot of our hopes, dreams, and quirks. As the Voyagers sail through the galaxy, these records hold the sounds, images, and spirit of Earth, waiting for someone or something to find them. Could this golden disc be the key to connecting with an alien civilization? Let's dive into the story of the Voyager Golden Record and why it's one of humanity's most audacious gestures. Imagine holding the Golden Record in your hands. It's a gold-plated disc about the size of a vinyl LP, gleaming under the faint starlight. You feel a rush of awe, knowing this small object was built to outlast civilizations, drifting through space for millions, maybe billions of years. The record is a cosmic playlist, packed with music, greetings, and sounds from Earth. Everything from Mozart to whale songs to the sound of a mother's lullaby. It's like humanity decided to send the universe a mixtape with a note that says, "Hey, we're here, and we've got some great tunes." You can't help but wonder, what would an alien think of our taste in music? Let's set the scene. It's 1977, and NASA's preparing to launch the Voyagers. The idea of sending a message to extraterrestrials is both daring and dreamy, spearheaded by Carl Sagan and a team of visionaries. They had just 6 weeks to create the record, racing to capture the essence of humanity. Picture the team in a cramped office, debating what to include. Beethoven or rock and roll? A thunderstorm or a heartbeat? The result is a record that's a masterpiece of science and art. Carrying 115 images, music from around the world, greetings in 55 languages, and natural sounds that paint a picture of life on Earth. It's a bold statement. We're diverse, we're curious, and we're reaching out. What's on the record? A treasure trove. The images, encoded in analog, show everything from a sunset over the ocean to a bustling city street to a diagram of human DNA. The music spans cultures. Bach's Brandenburg Concerto, Chuck Berry's Johnny B. Good, traditional Navajo chants, and more. The greetings range from ancient Akkadian to modern Mandarin, with messages like peace and happiness to all. And the sounds? Waves crashing, birds chirping, a baby's laugh, even the rhythm of a heartbeat. You can almost hear it now, that steady thump-thump echoing across the cosmos. A reminder that we're alive and dreaming of connection. Here's a quirky detail to make you grin. When the team chose Johnny B. Good, some NASA officials worried it was too juvenile. Carl Sagan's response? There are a lot of teenagers out there. It's a perfect touch of humanity, serious science with a dash of rock and roll attitude. Imagine an alien civilization finding the record and cranking up Chuck Berry on their cosmic speakers. Would they bob their heads, or whatever they have, to the beat? It's a fun thought that captures the record's playful spirit. The record isn't just about vibes. It's practical, too. It includes a map showing Earth's location relative to 14 pulsars, cosmic lighthouses that emit regular pulses. There's a diagram explaining how to play the record, with a stylus and binary instructions etched on its surface. It's like humanity said, here's our address and here's the user manual. But here's the wild part. The Voyagers are now so far out, they might detect those pulsar signals themselves. If they picked up something mimicking a pulsar's rhythm, it could spark speculation. Is it just cosmic noise or a reply to our message? That's the kind of question that fuels late-night debates among astronomers. Let's ground this in history. The Voyager Golden Record was inspired by the Pioneer plaques of 1972 and 1973, which carried simple drawings of humans and Earth's location. But the Voyager record went bigger, capturing the diversity of human culture in a way that's both universal and deeply personal. Created during the Cold War, a time of global tension, it was a gesture of hope, a way to say we're more than our conflicts. Carl Sagan wrote that the record was a chance to tell the universe, we're trying to understand our place in the cosmos. The Golden Record sparks lively debates. Some scientists call it a long shot. Space is vast, and the odds of an alien finding it are tiny. Others see it as a profound act of self-definition, a way to say who we are, even if no one ever listens. There's also a philosophical question. What would aliens make of us? Would they see us as curious explorers, or just a noisy species with a knack for music? The Voyager's data from interstellar space, those plasma waves and cosmic rays, adds another layer, prompting scientists to wonder if we should analyze anomalies for artificial signals. It's a stretch, But the record keeps the dream of contact alive. As you picture the Voyagers carrying these records through the stars, imagine their golden discs glinting faintly in the cosmic darkness. There's no sound in space, but if there were, you might hear the faint echo of Earth's heartbeat, encoded on the record, pulsing through the void. The spacecraft are battered by cosmic rays, their aging tech still carrying humanity's message. Back on Earth, we wonder what might happen if someone finds it. A moment of connection across the stars. It's a lonely journey, but it's thrilling. Like sending a letter to a friend you hope to meet someday. For a light-hearted break, think of the Voyagers as cosmic DJs, spinning their golden records for a galactic audience. Built with tech from the disco era, they're out there, dropping beats for the stars. If they could post a status update, it'd probably say, "Still carrying the hits, ready to jam with E.T." And here's a fun thought. If aliens find the record, they might think Earth is a planet of musical geniuses with a weird obsession with whales. The golden record is humanity's voice in the cosmos, a message of hope and curiosity. As the Voyagers drift further into the unknown, their records carry our story, waiting for someone to listen. Whether it's aliens or just the stars, the golden record is our way of saying we're here and we're dreaming big. Next up, we'll explore how these aging spacecraft keep going, defying the odds with tech from another era. You're riding alongside Voyager 1 and 2, deep in the interstellar void, where the stars are your only landmarks. These tiny spacecraft, launched in 1977, are humanity's farthest explorers, drifting over 15 billion miles from home. Built with tech older than most of your apps, they're still sending whispers from the edge of the cosmos, defying every expectation. How do these relics of the disco era keep going in the harshest environment imaginable? It's a tale of grit, ingenuity, and a sprinkle of cosmic magic. Get ready to dive into the nuts and bolts of Voyager's survival and uncover why their endurance is nothing short of miraculous. Picture yourself in NASA's Jet Propulsion Laboratory, staring at a flickering monitor displaying Voyager's faint signals. You feel a mix of awe and tension. Those signals are traveling across billions of miles, carried by machines that predate the internet. The Voyagers are like vintage cars cruising the galactic highway, their engines humming despite decades of wear and tear. Every byte of data is a triumph, a reminder that these spacecraft were built to outlast their creators' wildest dreams. You can almost hear the hum of old computers in the control room, smell the faint aroma of coffee as engineers work to keep these cosmic pioneers alive. Let's rewind to 1977. The Voyagers launched in an era of bell-bottoms and 8-track tapes, with computers that had less memory than a single emoji, 69.63 kilobytes to be exact. That's barely enough to store a tweet, let alone run a mission to interstellar space. Their power comes from radioisotope thermoelectric generators, RTGs, which use decaying plutonium to generate electricity from heat. Think of the RTGs as the spacecraft's beating heart, pumping out just a few hundred watts when new. But here's the catch. The plutonium decays over time, and after nearly 5 decades, the Voyagers are running on the cosmic equivalent of a dying battery, producing less than half their original power. How do they keep going? It's all about clever engineering. The Voyager's instruments, like their plasma wave detectors, cosmic ray sensors, and magnetometers, were designed to be power efficient, sipping electricity like a hiker rationing water. Over the years, NASA has turned off non-essential systems to save power, a bit like unplugging your fridge to keep the lights on. By 2025, several instruments have been shut down, prioritizing those that can study the interstellar medium. Every decision is a high-stakes gamble, balancing science with survival. You can feel the weight of those choices The quiet tension as engineers decide which piece of the mission to sacrifice next. Here's a quirky detail to make you smile. The Voyagers stored data on an 8-track tape recorder, the kind your grandparents might have used to play ABBA. This clunky device records data when the spacecraft can't transmit in real time, then plays it back to Earth at a snail's pace. It's like sending a postcard via carrier pigeon, yet it's still working, beaming data across billions of miles. Imagine trying to run a modern app on tech that old. It's a testament to the engineers who built Voyager to last. Let's anchor this in history. The Voyager program was born in the 1970s, a time when NASA was riding the high of the Apollo missions. Engineers designed the spacecraft with redundancy and durability in mind, knowing they'd face decades of radiation, extreme cold, and cosmic rays. The RTGs were a bold choice, untested for such long missions, but they've outperformed every expectation. By 1989, when Voyager 2 sent back breathtaking images of Neptune's azure clouds, it was already a legend. Now, in interstellar space, it's a marvel, proving that human craftsmanship can withstand the cosmos. The challenges are daunting. The Voyager's signals are incredibly weak, less than a billionth of a watt by the time they reach Earth. NASA's Deep Space Network uses massive 70-meter antennas to catch these whispers, like trying to hear a pin drop in a storm. Sending commands to Voyager takes over 40 hours round trip, so engineers must plan every move with precision, anticipating problems before they arise. Radiation in interstellar space degrades the spacecraft's circuits, and their thrusters, used to keep antennas pointed at Earth, are running low on fuel. Scientists debate how long the Voyagers can last. Some predict 2030, others hope for 2035. It's a race against time, a question of when the final signal will fade. As you imagine the Voyagers out there, picture their antennas locked on Earth, sending data through a barrage of cosmic rays. There's no sound in space. But if there were, you might hear the faint hum of their RTGs, like a heartbeat slowing with age. The spacecraft are battered, their solar panels useless in the dark. Yet they keep talking to us. Back on Earth, the NASA team cherishes every signal, knowing each one is a gift. It's a lonely journey, but it's inspiring, like watching a marathon runner push through the final miles against all odds. For a light-hearted break, think of the Voyagers as the ultimate overachievers, refusing to retire despite their age. While most 1970s tech is rotting in landfills, these spacecraft are out there, working overtime in interstellar space. If they could talk, they'd probably say, "Retirement? I'm too busy exploring the galaxy." And here's a fun thought. If Voyager sent a selfie, it'd probably show a weathered spacecraft with a cocky grin saying, "Still got it after all these years." The Voyager's survival is a testament to human ingenuity. They're showing us that even with limited tech, we can reach the stars. Their endurance challenges us to keep pushing, to build better, to dream bigger. As their power fades, every signal is a reminder of what we can achieve when we dare to explore. Next up, we'll reflect on the Voyager's legacy and what their journey teaches us about our place in the cosmos. You're standing under a star-filled sky, feeling the vastness of the universe stretch out before you. Somewhere out there, Voyager 1 and 2 are drifting through interstellar space, humanity's farthest explorers, carrying our story to the stars. Launched in 1977, these tiny spacecraft have journeyed over 15 billion miles, defying time, distance, and the harshness of the cosmos. As their signals grow fainter, their legacy grows stronger, teaching us about resilience, curiosity, and our place in the grand cosmic tapestry. What do the Voyagers mean for humanity? And how do they inspire us to keep reaching for the unknown? Let's reflect on their monumental impact and the lessons they offer for our future among the stars. Imagine you're in NASA's control room, eyes glued to a monitor as Voyager's faint signals trickle in from billions of miles away. You feel a surge of awe, maybe a touch of disbelief. These machines, built in the era of disco and rotary phones, are still talking to us from interstellar space. It's like getting a letter from a friend who's been traveling for decades. Their words still vibrant despite the distance. The Voyagers aren't just spacecraft. They're symbols of what we can achieve when we dare to dream big. They've shown us Jupiter's storms, Saturn's rings, and the Heliopause's mysteries, all while carrying golden records that proclaim, "This is who we are." Let's step back to 1977. The Voyagers launched in a world buzzing with optimism and ambition, fresh off the Apollo moon landings. Scientists like Carl Sagan saw space exploration as a way to unite humanity and spark wonder. The mission was audacious. Send 2 probes to explore the outer planets and, if possible, venture beyond the solar system. The Voyagers delivered beyond imagination, sending back images that redefined our view of the cosmos. Jupiter's swirling great red spot, Saturn's intricate rings, Neptune's ethereal blue glow. Now, in interstellar space, they're probing the galaxy's edge, detecting plasma waves, cosmic rays, and magnetic fields that challenge our understanding. You can almost hear the cheers in NASA's control rooms, where engineers still marvel at every signal. The legacy is multifaceted. First, it's about endurance. The Voyagers were built with 1970s tech. Computers with less memory than a single text message, powered by radioisotope thermoelectric generators, RTGs, that convert decaying plutonium into electricity. Those RTGs are fading, producing less than half their original power. Yet the Voyagers keep going, their instruments carefully rationed to study interstellar space. It's like watching a vintage car still cruising the highway, outlasting newer models. Their resilience teaches us that human ingenuity can conquer even the harshest environments, inspiring us to build things that last. Here's a quirky detail to make you grin. The Voyagers are humanity's longest-distance pen pals, their signals taking over 22 hours to reach Earth at the speed of light. If you sent Voyager a "How's it going?" message, you'd be waiting nearly 2 days for a reply. It's like texting someone on a cosmic dial-up connection. Yet NASA's Deep Space Network catches those whispers with massive antennas, proving our commitment to staying connected. Imagine Voyager sending a postcard. "Greetings from interstellar space. Wish you could see the view." Historically, the Voyagers are a product of the 1970s space age, a time when humanity believed we could conquer the stars. The mission was a bold bet, backed by visionaries who saw exploration as a way to transcend earthly conflicts. The golden records, with their sounds and images of Earth, were a gesture of hope, a message to the cosmos that we're here and we're curious. The Voyager's success, surviving decades, crossing into interstellar space, shows that bold dreams can outlast doubt. They're a reminder that exploration is about more than science. It's about the human spirit. The Voyagers spark big questions. Scientists debate the meaning of their interstellar data, those plasma hums, magnetic anomalies, and cosmic ray surges. Are they clues to new physics, or just the galaxy's quirks? Beyond science, there's a deeper question. What does it mean to send our story into the void? The golden records are a long shot, with slim odds of being found. But they're a profound act of faith in our shared existence. Some argue it's a futile gesture. Others see it as a way to define who we are. You can feel the weight of that debate. What is our place in a universe so vast it defies imagination? As you picture the Voyagers drifting through the stars, imagine their golden records, glinting faintly in the cosmic darkness. There's no sound in space, but if there were, you might hear the echo of Earth's heartbeat, encoded on those disks, pulsing through the void. The spacecraft are battered, their power fading, yet they keep going, carrying our story to the stars. Back on Earth, we listen to their signals, knowing each one could be the last. It's a humbling scene, like watching a lone candle flicker in a storm, its light small but unyielding. For a light-hearted break, think of the Voyagers as cosmic adventurers who never got the memo to slow down. While most 1970s tech is in a museum, they're out there, exploring the galaxy like the ultimate road trippers. If they could post a status update, it'd probably say, "Still cruising, still curious, still the coolest." And here's a fun thought. If the Voyagers had a personality, they'd be the grandparents who've seen it all, but still have epic stories to share. The Voyagers' legacy is a challenge to keep exploring. They teach us to dream big, to build things that endure, to ask questions even when the answers are far away. As their signals fade, they urge us to send new probes, to reach further, to keep wondering. They remind us that our place in the cosmos is defined by our curiosity. So, what does the Voyager's journey mean to you? Drop your thoughts in the comments, and let's keep the cosmic conversation alive as we dream of what's next.